You have been given another question here from a topic called calculus, and the question reads: a curve y is equal to x cubic plus 4x squared minus 3x plus k passes through a point P negative 2, 9. Find the value of k. So there's a curve whose equation is y is equal to x cubic plus 4x squared minus 3x plus k. So we'll be told a curve y is equal to x cubic plus 4x squared minus 3x plus k passes through P whose coordinates are minus 2 and 9. So someone is asking you to get the value of k. It is very simple. And you see, at the end of the day, the value of y that I need to have should be equal to the answer I'm going to get here when the value of x is substituted into this equation. So that means it's very easy for us to get the value of k, the constant. So what do? We just pick this pair of values, the two values, the value of x and the value of y, this coordinate, and plug those values into the equation so that we can be able to get the exact value of k. So what do? We shall come here and say y is equal to x cubic plus 4x squared minus 3x plus k, or constant. So we know our y is 9, so 9 is equals to then x. So this is x and this is y. So our x is negative 2, so negative 2 cubic plus 4 into negative 2 squared minus 3 into negative 2 and plus the constant k. Yeah, because at that point, when you plug that value of x into that equation and the value of y into that equation, you will get the constant k. So this is 9 is equals to 8 negative plus 8, yeah, negative 2 squared is 4. So 4 times 4, that is 16, sorry, then plus 6, then plus k. So negative 2 cubic, that is negative 8. Negative 2 squared, 4. 4 times 4 is 16. Minus 3, minus 2. Minus 3 times minus 2, that is plus 6, then plus k. So 9 is equal to minus 8 plus 22 plus k. So that will be 9, okay, plus 8 minus 22 is equals to k. Why? This becomes positive, this becomes negative. So 9 plus 8, then minus 22. So this is what? 17 minus 22, that should be given as k. So our k is negative 5. So the value of k is negative 5. The value of k is negative 5. The second part, find the equation of a tangent to the curve at P. The equation of the tangent to the curve at P. So I can say to come here with this as my curve. Okay? And if this becomes my curve, I can have this as my equation. Okay? And let me have this one as my tangent. And tangent is just a line that touches the curve at a particular point. So this is my line. So this can be my tangent. Okay? This is going to be my curve, whose equation is now given as y is equals to x cubic minus, or that is plus 4x squared minus 3x, then minus 5. Why minus 5? Because the value of k is negative 5, so that becomes minus 5. So that's the equation of the curve. It is the line or the tangent. So the tangent touches the curve at that point. And that point is actually given as point P. And we are told the coordinates of P are negative 2, 9. Correct. So you have been given a curve. We have gotten the value of k. We have placed that value of k into the equation. So the equation reads y is equals to, okay, x cubic plus 4x squared minus 3x minus 5. So that's the equation of the curve. We have been told there's a tangent or a straight line that touches the curve at that point, point P, whose coordinates are minus 2, 9. We have been told to get the equation of that tangent. You need to ask yourself, how do I get the equation of this tangent? So just do this. You know very well, if you have been told to get the equation of a tangent, equation of a tangent. And I've told you a tangent is just a line. So how do I get the equation of a line or the equation of a tangent? I just come here and say for me to get the equation of a line, the equation of a tangent, I need two things. One, a coordinate that can be found on that line, and one of these things you are supposed to have is this. So which is -2, 9, and we also need to have what we call the gradient. Now, it is very difficult for us. We know very well -2, 9 is a coordinate that is shared by both the line and the curve, because the line touches the curve at this point. And at this point, this line and this curve must be sharing the value of x and the value of y. So they both have a value of x as -9 and the value of y as 9. The value of x as -2 and the value of y as 9. So at that point, how do we get the equation of this line? We shall first be able to get the gradient of that curve. Notion of the gradient of the curve, and of course the tangent and the curve have the same gradient at a particular point. So we're going to say gradient of the curve, gradient of the curve, gradient of the curve is equal to, first we get what we call dy dx. dy dx, so we're going to have this one differentiated, or we get the derivative function or the gradient function. Look at that. So we shall have differentiate this. You are supposed to actually take the power, multiply by the coefficient, then reduce the power by 1. So we shall assume there's 1 here. So 1 times 3, that is 3. Then that is x. Then you reduce the power by 1. So you shall be able to have 2. Then plus. Again, take the power 2. Multiply by the coefficient of x, that is 4 times 2, that gives us 8. Then reduce the power by 1, that makes x. Then say less. We shall put here 1. Take the power 1 times 3, that gives us 3. Then reduce the power by 1, that means 1 minus 1, that means that's going to be x minus x raised to 0. That gives us just 1. So you can drop the constant when you're differentiating. So this is the dy dx. And at that point, what's the gradient? It is the dy dx. dy dx helps you get the gradient of a curve. So we know that at that point, the gradient of this curve is going to be something if we actually take this value of x. So when x is 2 at this point, what's the gradient of that curve at that point? So we can just substitute. Let's come here and say 3 into 2 squared plus 8 into 2 minus 3. So that gives us 3 into 4 plus 16 minus 3. So that is going to be 12 plus 16 minus 3. 12 plus 16, that is 28 minus 3, that gives us 24. So the gradient of the curve at that point is 25. And once you know the gradient of the curve at that point is 25, that means the gradient of the tangent must also be 25. Why? Both the curve and the tangent must have the same gradient. So I want to get the equation of that line. How do I get the equation of that line? I'll come here and say gradient is equals to y, changing y, of course y2, y1, x2, x1. So I know the gradient is 25, I can say 25 over 1. See? So the gradient of this line or tangent is 25 also. If the gradient of the curve is 25. Then I have is equals to y minus, the value of y here is 9, because you need a pair of coordinates and the gradient. So we say gradient 25 over 1 is equals to y minus 9 over x minus -2. So this is the same as 25 over 1 is equals to y minus 9 over x plus 2. So we can proceed. We are going to have cross multiplication. So it will be y minus 9 is equal to 25 times x, that gives us 25x, then plus 50, y, 25 times 2. Okay, so this is the same as y is equals to 25x plus 50 plus 9. So our final answer becomes y is equals to 25x plus 59. That becomes our final answer as far as the question of that tangent is concerned.
So that becomes now our answer in as far as the equation of that tangent is concerned.